So let's consider our visualization when we think about the possibilities for tuning MapReduce. So again, we see that we have 6 different places where we have the opportunity to tune. Now we're going to start in this section and talk about physical tuning. There's a lot of tuning that we can do through our MapReduce code, but it has to work in conjunction with physical tuning. And this relates to physically what the data looks like when it comes in, where it lives, what's the capacity of the system that it's being processed on, what's the connectivity to the output location, and the capacity of the output destination as well. So you can think of it as a cycle. So you can do optimization on the upper right before the job runs. So what are some kinds of optimizations that I've completed before jobs run? Well, I mentioned it earlier, but I'll call it out again. The most common one is pre-processing on the data. So what does that look like? I might take text data and do something like remove all the non-English characters, remove all the punctuation, or do some other type of parsing just to make the actual MapReduce, if, for example, I'm analyzing the words for maybe sentiment analysis, a little bit faster and easier. So pre-processing on data is a common optimization task. Now you can also optimize on load of the data. How you might do that is you might change the compression ratio, for example, so that the size of the data is actually smaller. You might break the data into different sized chunks. You might change the scalability of the data load. This is particularly an option if you're using cloud-based Hadoop scenarios where you can spin up additional data nodes and spin them down quickly and cheaply. Then you're going to optimize the map phase of the job, and that usually deals with code and how you write the code. So we'll look at that in greater detail in another movie. You can also optimize the default shuffle phase of the job. That's a highly complex task, and it's something that in production I've only seen a couple of times. So my recommendation is to let that execute in the way that it's designed unless you have a very compelling business reason to make a change to it. You can then optimize the reduce phase of the job. I see this happening less frequently than the map phase. I'll be giving you some techniques in subsequent movies on how to do that. And you can also optimize after the job completes. Now, what could happen there is you could take a really bulky job and you could break it into 2 jobs so that the first job was more lightweight and processed more quickly and possibly using greater parallelization so that the second job could process in a more timely manner. You really want to think in terms of chunks or Lego bricks when you're thinking in terms of MapReduce design. So I talked about optimization before running a MapReduce job, and I talked about a lot of the items on this page, but I'll just make sure to be inclusive. So I talked about compression, using a compression algorithm that's most optimal for your situation. And compression is a balance between how much compression you can get and how that compression affects the processing. If in your mapper you have simple logic, you can take advantage of a high level of compression. However, the opposite is also true. If you have very complex mapping logic, then sometimes you need to go with a more lightweight compression. Now, I didn't mention encryption. For some data, encryption is part of the business rules. You have to consider the overhead of working with encrypted data, which sometimes will entail de-encrypting it and sometimes won't. When we think about physical MapReduce optimization possibilities, the number one thing that I see out there in the wild is that the cluster configuration parameters have somehow been changed, and there's not a good business reason for those changes. People are just trying things out, and it's not documented. And what happens is on different MapReduce jobs, because we have non-standard configuration parameters, there's unexpected behavior. So if you're going to change from default cluster configuration parameters, make sure you have, number one, a compelling business reason. And an example of this would be if you want to change from the default replication of 3 nodes for each piece of data in HDFS to some other value, 2 nodes, no nodes, 5 nodes, for example. Have a compelling business reason for doing so, and make sure you document that so anybody else working with the cluster can understand. Another thing is you should take a look at both unused resources, so data nodes that aren't used during the majority of your MapReduce jobs, or overstressed resources, data nodes where you have a lot of spillage because your map processes can't fit into memory on all the data nodes. They spill out to disk, which takes a lot longer. From the highest level, are you using any sort of cluster monitoring tools? Now, we've seen in the Hue interface that we have lightweight monitoring, But this is part of the value proposition around the vendor distributions. They provide really industrial strength cluster monitoring tools that help you get the best value and the best performance out of a Hadoop cluster, and they're really worth investing in. One of the ones that I've looked at is Ganglia. There are many out there, tens if not 50 of them. There's a lot of different companies working in this space because it is complex, and you do want to make the appropriate use of the physical resources in your cluster. It's very easy, obviously, in a Hadoop cluster to just add more nodes, but you want to do it in an intelligent fashion and make sure that those nodes are actually being used because of the configuration settings and the MapReduce jobs that you're running through your Hadoop cluster. And I mentioned it, but the simplest possible optimization is to add more nodes. So again, you don't want to overlook the obvious. Hadoop is designed to scale. So especially if you're using cloud-based implementations, I find a really effective optimization technique when you're running against time deadlines, and where maybe you have changes in your staff, so you can't rework your MapReduce jobs, some other complexity, just spin up more nodes. Another variant of this is if you have an on-premise cluster and it's getting stressed, and you really don't want to go out and purchase some more hardware, you can augment on-premise clusters with a partial implementation on the cloud. This is a sophisticated use of Hadoop, but I see really smart companies doing this where they'll offload some of their one-off batch processes. I've done this with some companies that process genomic information. They have the initial processing of the large amount of genomic information, which they need to aggregate and compare. They'll push that off onto an Amazon Hadoop cluster and use spot pricing, as I talked about earlier. They can get a really cheap and effective, quick process of a lot of data, and then they can pull that data back down and they can work on it locally. So this idea of mixed, both local and cloud-based Hadoop is really coming into play. And it's something for you to think about when you're optimizing from a physical standpoint your Hadoop implementation.